In this problem, we need to determine the equation of the reflected image of a circle whose equation is given by x squared plus y squared plus 8x minus 16y plus 64 equals to 0 across the line of reflection x equals to 0. So first, let's try to do one thing. Let's try to rewrite this given equation of the circle in a standard form. The standard form states that if we have a circle whose center is given by the coordinate h comma k and has a radius of r, then the standard form of the circle is given by the formula x minus h whole squared plus y minus k whole squared equals to r squared. Now in our case, we have the equation of a circle. So it's given here that the equation of the circle is x squared plus y squared plus 8x minus 16y plus 64 equals to 0. Now this particular equation, this is not given in the standard form. So let's label this as equation number 1. And what we'll do, we'll try to convert it into the standard form. To do that, so let's first write all the terms containing x together. So we have x squared plus 8x. Then we have all the terms containing y together, y squared minus 16y. And we'll transpose 64 to the right hand side, and that will be negative 64. Now our goal will be to convert x squared plus 8x to a perfect square as well as y squared minus 16y. To do that, all we have to do is rewrite the two terms as x squared plus, so we're going to rewrite 8x as a multiple of 2. So we have 2 times x times 4. So this number 4 is going to tell us that we need to add square of that particular number, so 4 squared, and also we'll have to subtract 4 squared from it. That's an extra term. Similarly, we go to the next one, y squared minus 16y. So we have y squared minus, the 16y can be written in the multiple of 2 as 2 times y times 8. So this number 8 is going to tell us that we have to add square of 8 and subtract 8 squared from it, because 8 squared is an extra term that we have added, and this will be equals to negative 64. Now in doing so, x squared plus 2x times 4 plus 4 squared, this is nothing but x plus 4 whole squared. Then we have y squared minus 2y times 8 plus 8 squared. So this is going to become y minus 8 whole squared. Next, what we'll do, we'll transpose negative 4 squared, negative 8 squared to the right hand side. So we have 4 squared, that's 16. 8 squared, that's 64. Then we have negative 64. So 64 and 64 cancels out. And then we can have x. So we were going to write plus 4 as negative of negative 4 whole squared plus y minus 8 whole squared, and that will be equals to 16. So 16 can be also expressed as a perfect square. We have 4 squared. We have done this because if we now compare it with the standard form of the circle, we get the value of h, so that will be negative 4. The value of k is going to be positive 8, and the radius of the circle is going to be equals to 4. That means we now have the coordinate of the center, because the center is given by h comma k. So we have obtained the value of h, which is negative 4, and the value of k is 8. So that's the coordinate of the center of the circle. And we have the radius r equals to 4. So let's try to sketch this particular circle. So we will consider our Cartesian plane and the two axes. So let's consider the coordinate negative 4 comma 8. So we have to go 4 units in the negative x direction, and from the negative 4 we will move 8 units upwards. So let's say suppose our circle has the center here at negative 4 comma 8. So this distance is 4, which incidentally is also the radius of the circle. So what we'll do, we'll try to construct a circle which has a radius of 4 units, and then it has the coordinate of center at negative 4 comma 8. So this is the radius of the circle. Now let's go back to our original problem. So in our problem, we have to find out the equation of the reflected image of the circle, not this circle, because the equation is already provided to us. We'll have to find out the mirror image of the circle, which is reflected along the line of reflection x equals to 0. So what is the line that represents x equals to 0? So it's the y-axis. So the y-axis has the equation x equals to 0. So that means we'll have to find the equation of a circle. So let's say that this is the mirror. That means if we reflect it about the y-axis, so this is going to be our new circle, and this is the reflected circle of the original yellow circle, and we need to find out the equation of this particular circle. So let's say assume that this is the coordinate of the center h comma positive k. Now the radius of the circle, so that's going to be fixed. It's going to be 4 units. So what we'll do, we'll drop a perpendicular from the center. So let's call the center C prime, and the center of the original circle is C. Now C prime, when we drop a perpendicular on the x-axis, well, let's say we have C prime A. So this distance we need to determine. So this value is going to be equals to 8, because that's going to be exactly equal to the height of the center C. So this measure is 8 units. And what's the distance of the x distance from the y-axis? That was going to give us the y coordinate. So this is equivalent to the radius of the circle, that's 4 units. So that means the center of the new circle is going to be 4, 8. So now we have the center, the new center, which is denoted by h, k. So we found out that this center has the coordinate 4, 8. So that immediately tells us that the value of h is going to be 4, and the value of k, the y coordinate, is going to be 8. And also we have the radius. So radius is going to be fixed at 4 units. Now we can find out the equation of the circle, which is going to be x minus h whole square plus y minus 8 whole square. That's equals to the radius of the circle, that is 4 square. So we can further simplify this to get x squared plus y squared minus 8x minus 16y plus 64 equals to 0. So this is going to be the equation of the reflected circle, which is reflected about the y-axis, or the equation of the line x equals to 0.